Check. Everybody. We'll start in just a minute. I'm not 100% sure that people can hear me right now, so the waiting game begins here. But we'll start in just a few minutes. Okay, so we're good. All right. So, again, we'll start in a few minutes. Today we are going to talk about analyzing solar cell data, which I'm excited about. And I'll give you some examples of solar cell data, and we'll do some of the data crunching and that sort of a thing. I like solar cell data for a million reasons, and we'll dig into it. Where do you get the data? What kind of things can you do with the data? What kind of questions can you address? And so on and so forth. Let's see. I have Charty Party in here, so I have some show and tell. Just give me a second. So that'll come in just a minute here. I'm quieter than I was previously. That's not good. Let's see if I can turn myself up. Is that? I think that's turning the mic up as far as it will go. Let's see. Yeah, that's as high. Oh, I'm on the webcam. I'm not on the. Turn that way on. All right. No business. No, I just turned the volume. I had it for a second. It was on the microphone that was attached to the webcam. So that's why it wasn't working so well. Cool. So yeah, I tapped this. That should annoy you guys. Okay. All right. So close to 12 o'clock. Let's see. So I think I'll go ahead and say some preliminary things. Our data science training, in many ways, is based on some experiments that we did at Metro High School in Columbus. And so we did a 2-week-long, okay, so can't hear me now. Really? Scott and Julie, let me know if my audio is terrible or not. Because on my end it looks okay, like that. But you can only hear what I'm saying by the captions. Maybe I turned up too high. Can you turn it down some? Can that help? I can see that my audio is doing something, right? So I don't know why it's... The previous mic is better. That's not great. How's this? Is this better? Please tell me this mic is better. For the love of God, please tell me this mic is better than what I was doing. If it's not, I'm gonna cry. Much better. Okay. All right. See, there's a 20-second delay. So like, I change mics and then I feel like that's gonna work better, but I'm still seeing messages that it was terrible. So anyway. Okay. So our data science training that we're doing is in many ways based on what we did at Metro High School in January 23 and January 24. We had a 2-week-long data science mini course that we ran about an hour and a half a day. And the first time we did it, we included this solar cell activity. Second time we did it, we were more oriented towards public health and that sort of a thing, so we didn't get a chance to do the solar cell thing. And so what you're going to see is based on a thing we actually did, a thing that we actually did in a classroom with students, and so I could talk about how it went and that sort of a thing. Before I get into that, a couple of general data science fun stuff that I wanted to talk about. The first one is Charty Party. So we are big fans of the Charty Party in the STEM Coding Project, I can tell you. And this is a game where essentially you get, the way that it's played is that you get, students will get a card that has an x-axis and a card that has a y-axis. And so, like this one says famous chefs, and then the student has to find, or here's another one, organization level. It's pretty silly, right? And then the game is to find a silly y-axis that in some way makes sense with the x-axis. So here's a silly y-axis, you know, ability to stay awake throughout the whole day, that sort of thing. So it's a silly game. It reminds me a little bit of Apples to Apples, and it's a good way to think about what makes for a good plot. And it even gets into one of the challenge questions, because there's a teacher guide, is actually asking how you would design a study to do different things. Which, when I first read the teacher guide and said that you should take something silly like this and design a study around it, I thought it was a really bad idea. But when we actually did it with students, it actually kind of made sense. So like, there's silly things of like, you know, ability to go on dates and like, or the loudness of farts, and like you can literally have a discussion about how you would try to probe those things of like measuring the sound or doing a survey in your school to try to find these things out. So we love the Charty Party. Our friend Kristen Hunter-Thompson over at DataSpire recommended it to us, so I told you about DataSpire yesterday. She has a nice YouTube channel. There is one thing that you have to know with Charty Party, if you're going to do it, and it's very important, it's the all ages, okay? There's two different versions. There's the original Charty Party, and then there's the all ages Charty Party. Let's see if I can find it. I had it up earlier. And so is it this one? No. So the important thing is that do not buy the original Charty Party. The original Charty Party is like an adult game. The all ages version is the one that you want to put in the schools. That's not going to get anybody in any trouble, Okay, so that's advice number one. Advice number two is a big thing in data science, a big part of data science education is what's called the data cycle. And there's many different diagrams of this. So earlier today I went to Google Images and I just searched on data cycle, and all of these things came up. And some of them are more oriented towards adult learners than high school and middle school learners. But I kind of like this one, which is from I think it's made by UCLA people. And basically, the idea of it is that there's a kind of a cyclical process here as it relates to working with data, right? So you have your questions that you might want to answer by gathering data. You either gather data, you consider data, you go search for data on the internet. Somehow you obtain the data, you look at the data, and then you try to analyze the data. You think critically about the data, you interpret those results, and maybe those results give you more questions that you might want to ask, and then you do the whole thing over again, right? So this is a real core thing that every data science class has to have. I'm on a committee with the group Data Science for Everyone out of University of Chicago. We're trying to design K-12 data science standards, and this data cycle is definitely going to be a part of it. So we don't have an official STEM coding data cycle diagram that we like. Maybe someday we should make one, but whatever one you think works best for your students, if you find a better one than this one, go ahead and use that. But just that's the spirit of it. By the way, a minute ago, we're not sponsored by Charity Party in any way. We don't make any money from Charity Party. It's a game that we like, so no one's sponsoring us to plug Charity Party. It's so good that it just stands on its own 2 feet in terms of fun stuff you can do in the classroom that gets kids excited about data and graphs and those sorts of things. So the reason I mentioned the data cycle is today we're going to kind of use this because we're going to look at some data, we're going to analyze some data, and then it's going to lead to more questions that we might have that we might want to answer. And the data specifically is from solar data. Now, we started doing this because I actually have solar panels on my house, sort of like 10 feet that way, and we were analyzing data from my solar panels, and then a friend of mine gave us his solar data, and the thing that you are trying to get is daily data for how much energy that it generates. And so what we've done is we've compiled a whole bunch of data, and we put it in the GitHub page for the STEM Coding project. So I want to thank Julie Butler for helping us to do that. And so if you go to let's see, so GitHub/stemcoding/stemcoding.github.io, that will bring you to this page, which has a bunch of stuff in it. And then if you click on solar, you will find that there is a whole bunch of different solar data. I believe Solar 1 and Solar 2 is from Ohio. We haven't labeled that one very well. And so this is great because if you have a classroom and maybe you have multiple groups, you can give each student or each group a different data set to consider. What all these data have in common, and by the way, you're supposed to say these data because data is technically plural, so you don't want to say, it's incorrect to say this data, all this data, so you want to say these data. What all these data sets have in common is that they have multiple years of data in them. And so this one starts in 2018, and it tells how much data was how much energy was produced on each day. So January is a pretty cloudy month, right? So some days it's sunny and you get a fair amount of energy. Other days it's cloudy, you get half that. I'm sure if you keep looking, you probably find even less than that. So January, it's kind of hit or miss when it comes to solar data. And then the data just keeps going and going and going and going and going. And so what each of these data sets have in common is that they extend for multiple years. So this one goes from 2018 all the way to 2022. And that's important for some reasons that we'll get into in a minute. So you can download the data. So I believe if you click that little down arrow button, that allows you to download this file. This is a CSV file. You can open it in Google Sheets. You can open it in Excel. If you just plot it up, which I did earlier, if you just plot it up, where was I doing that? I had it all plotted up, and then it was... I just want to plot up the raw data so you can see what it looks like. I had it in Google Sheets. Here it is. So the raw data might look something like this. So a thing to do, going back to the data cycle, right? Here's the data. Here's the data. What questions do you have about the data? Or what do you notice about the data? What do you wonder about the data? So these are all classic math kind of exercises. So what do you notice? What's there, right? Why are there these 5 peaks here? Why is it so noisy? Why does it sort of drop down and drop back up again? So this is a fun conversation you can have with your class. And hopefully, without too much trouble, you can figure out that the lowest energy generation is during the winter, which is for a couple of reasons. It's not just because it's cloudy. It's also because in the northern hemisphere, the sun does not get very high in the sky in the winters. And so as a result, the intensity of the light reaching your roof is less, which is part of why it gets so cold in the winter. So that's why you don't get so much energy generation in the winter. But in the summers, the sun gets higher in the sky, the intensity of the light is higher, and you tend to get, it also tends to be a bit sunnier, right? So you tend to get much more energy during summer, but some days in the summer, it can be middle of the summer, it can be it'll just be cloudy all day and you get almost nothing, right? So there's a lot to unpack here. You can let the students sit on that for a while. And what you want to do is you want to try to make sense of this data. You want to try to sum the data and average the data and those sorts of things. So we have a worksheet that we developed, if I can find it. Is it up here? No. And the worksheet so here it is. I have put a copy of this worksheet in the Discord, on our Discord channel. So I don't have it up on the web that I can give you a URL, but I have a copy of the link, a copy of this file that you can find and you can modify. So just consider this is from the STEM Coding Project. Consider it Creative Commons, non-commercial, and you can kind of go through and think about what's here. And so this here. So one way to make sense of the data, given that it's as noisy as it is, and it fluctuates as much as it does, a thing that you could do to try to understand the data is, how do I zoom in on this thing? All right, whoops. So the thing that you could do is try to summarize it in the following way. So this is a different data set, right, because it started in 2017 instead of 2018. This is a different data set, and it sums up the energy generation in each month, right? And then it adds up all the energy generation for the month, and it will tell you how much energy was generated in the year. And then it does that for each year. and so that allows you to see some of the trends is one of the things you could do with this, right? So this is a different data set, and so a thing for your students to do is to try to mimic this and try to figure out for themselves what's happening with this. And there actually is an interesting trend here that we can talk about. So what you would do with that is that you would take the data, so you would download the data from the GitHub directory, and then you can. So I'm going to try to. This didn't work so well earlier. So you can take that data, and you can. I'm going to go in Excel here, and you can use Excel. You can use Google Sheets. It's up to you. And I'm going to use Excel for now, but I was using Google Sheets earlier. So you can open up the solar data. So I already kind of uploaded it, and this is what you get. It's going to give you these pound signs, which is a little bit annoying, but if you just sort of move this across, that'll sort itself out. And what you can do with the students is you can ask them, do you want to sum up the data monthly, bi-monthly, quarterly, that sort of thing. Honestly, a quicker thing is to sum it up yearly. And so what you could do is you could ask your students, and by the way, right now it's in viewing mode, but I want to change it to editing mode, so it might need to convert it back to Excel format or something like that. So now I'm in editing mode. And all you really need to do with the student, all you really need to do is to kind of scroll down and find when 2019 starts, and just find January 1st, 2019, right? And what you can potentially do is insert a row above that and just say, total for 2018. And then you use the sum command, so sum, and this would be, if you scroll up and look, B2 is the first data that we have, and then colon B366, right? Because there's 365 days in a year, right? And if you sum all that up, it tells you how much energy was generated in that year. So this would be 7,700,000 watt hours, something like that, right? So you can do that for each year. And so once you have this number, so this number is B367, and so you can go over here and you can do 2018, and then equals B367, and you'll record that. And then you can do it again for 2019 and come up with, see how much you get with that. Try to remember, it starts to get a little bit tricky, right? Because you have to remember, so we're talking about B367, right? So the next data point is B368. And so you start at B368, you go to so on and so forth, and you want to create another little thing here. So total for 2019 equals sum B367, I think it was, to B732, and that gives you a very large number. You got to expand this to get it. I think I must have messed that up. That doesn't seem right. 15, that seems like it's too much. It can't possibly be right. B367. Did I mess that up? B368. So I accidentally included the sum from the last one. Alright. So that gives me 7.9 million watt hours, right? So you just keep doing that. So you keep going up here. 2019. I've just forgotten which cell we're talking about. that was what, 2019? 7 something, right? 733. All right, so equals B 733. And so you do that for the different years, and then that allows you to see kind of what the trend is. And so if you do that for the different years, so this is what I get. What's interesting is that you find that over time, there does tend to be a decrease in the amount of energy that these solar panels generate. It's a multi-year trend. So interestingly, 2019 generated more energy than 2018, and who knows why that could be? Maybe it was less cloudy in 2019. There are seasonal variations. Some winters are worse than others. If you're like me and you live in Ohio, you know that very intimately, right? But over time, the solar panels generate less and less energy, right? So 7.1 million watt hours is a lot less than 7.7 or 7.9, and I don't have the numbers for 2023 and 2024, but I would wager to guess that it's even less. So a discussion to have with your students is at what point should we replace the solar panels on this system, right? So the panels are degrading. It's not necessarily the components, and that like there's inverters and stuff that are being used. Those things are probably fine, but the panels themselves, which face the sun day in, day out, those are getting worse over time. And you can do a little bit of financial math to try to figure out when you should make that transition. So if you can figure that each solar panel costs $300 or something like that, and maybe replacing the whole solar array might cost, you know, 15K or something like that. You can try to get an idea of at what point is this thing so diminished that it would make a lot of sense to just replace it. And what's interesting about that discussion is because it gets into a little bit of the ethics, right? Because and there's no right answer necessarily, right? Because some people would say that it's already declined enough, you should just replace it right now, right? Because we need to generate as much energy as we can from carbon-free sources, which is what solar is. And we should just replace it right now so it goes back up to this, or even higher, right? Because the solar panels have gotten better now since 2018. So some people would say, let's replace it right now. And that because of climate change, because of avoiding, asthma caused by coal-fired power plants, that sort of a thing. This is a discussion you can have with your class. The one other thing I wanted to say about this is that thinking of it in terms of a loss in efficiency. So solar panels have, so if you think of it being at 100% efficiency here, after a couple years, what do you get? Because the thing is that this line of best fit that you have, it basically has, let's see. This line of best fit is kind of difficult to interpret in that. It's kind of difficult to interpret, especially because we're starting from 2018. So it may take some thought to figure out, like, all right, this dropped by something like 10%. So, for example, a quick thing you could do would be to say that, all right, well, the ratio of 2022 to 2018 would be J3 divided by F3. Whoops. Why is that not working? Oh, F2. So J2 divided by F2. Right? So in 5 years, the efficiency has declined about 8%. And so the efficiency is declining at about 1.5% per year, something like that. But that assumes that it's linear, right? So a whole nother discussion we had with the students is like, we assume that this is linear, right? Do we know for sure that it's linear? Maybe it's, a quadratic function. Maybe it's a cubic function. And what's interesting is that you can try to address that question with the data that we have on our site, right? Because we have multiple different data sets, and supposedly one of the Denison University ones has 7 or 8 years of data on it, because you really would need multiple years to try to figure out, is this linear, or is there some curvature to it? So that's a whole other discussion you can have, which again gets to the Algebra 2 level math that we're talking about. There are national concerns that high school data science courses do not connect enough with advanced math, and so a way that you can do that is to try to think about, is this really a linear trend or not? And you can try to answer that. A reasonable question is where in the world do we get this data? So let me just say something about that real quick. So we found, I forget who told us about this, but so there's a site called SolarEdge, and a lot of people with solar panels have SolarEdge as their monitoring software. Mine is not on SolarEdge, by the way, but I use a different system. But for some reason, and we're grateful for this, the SolarEdge people, and on the login page for, if you want to log in to see your solar panels, they also have a list of public sites that if you just click this, it shows you all of the all the systems that are sharing their solar data publicly. And so what we did is that we went through this, and we tried to avoid looking at people's houses, right? We tried to look at schools and other kind of maybe government buildings and that sort of a thing, and we obtained the data that way. Now the funny thing is that the data that's provided here is on a daily basis, right? But the funny thing is that they already do the summaries, so you can click year, and it will show you the trends year over year. So this data set is from some sort of a school, but there's only, let's see, it's a relatively recent system, it seems like. It's only been around for maybe a year or two. And so we wouldn't have used this one necessarily. Is that right? Lifetime of energy? Yeah, installed in 2022. So we wouldn't have used this one because it hasn't been around for long enough, right? But you can look on this site and try to find new ones. But the funny thing is just that it already does all of these sums. So it already sums up the data from each month. And what you have to do is you have to click the daily data, which can be all over the place. I guess that's data just from today, right? Yeah, just from today, just this morning even. And so what we did is we took the daily data and we put it into one file so that the student is the one that has to sum up the data. So it's up to you whether you want to send the students to look at the data from this site, but I just wanted to be clear about where in the world we obtain this data and where it comes from and that sort of a thing. So so that's the basic idea. There's a lot of fun stuff in the worksheet that I haven't had so much time to go over, but there's a lot of questions. There's a lot of I think a lot of what I said has already kind of been covered here in the discussions that we've had. Yeah, so I guess Solar 2 and Solar 3 are from Ohio. Solar 1 apparently is Washington, D.C. So there it is. I'm going to go hop on Discord and see if there's any questions. Yeah, we hope you like it. If you modify it and you want to send us what you have, that would be great. But we hope you like this activity. Again, it does data science, but it's data science with like a physical science bent to it, maybe even environmental science, atmospheric science, that sort of a thing. So we love it to have more people using these kinds of data sets in a high school data science class. I haven't seen so much of this in when I go and I look at the high school data science courses that exist so far. So enjoy it, and thanks for tuning in. Any questions? How are we doing? Da-da-da-da. Cool. Alright, well I think we're good. So, alright, well I'm going to sign off, but feel free to ask questions on the Discord and interact with us there. And we hope you enjoy this activity that we've developed. Hopefully we'll make a video for it properly on the YouTube channel at some point, but we just wanted to share it with you in the meantime.